is 40 millisecond. That means I must put 40 millisecond equal to n into 20 millisecond. When we change the time-based setting, we do not change the time period or frequency of the signal, because that is the characteristic feature of that signal that we have connected to this device. And by changing the appearance on the screen, we are not changing the time period of that signal. So 40 millisecond that we calculated earlier with the time-based setting of 10 millisecond given, that remains unchanged. Yes, the time-based setting has changed now, and as a result, this n must change. That means if 20 is larger value now, n must be smaller, because the product will be the same as before. So that clearly means n will be 2 now, because 40 divided by 20 will be 2. So what will the trace look like now? The trace will be such that it completes itself in only 2 boxes. So this is how the trace looks like. So the new trace on the screen will be this. So immediately after you change the time-based setting, you have this shape of the trace on the screen, which clearly shows that now the wave is fitting in 2 boxes, 1 and 2. So in 2 boxes, 1 wave is fitting in, and this we have calculated from the same equation which relates the time period to the number of boxes times the time-based setting. So this is the simple formula that gives us various useful quantities related to the features of this trace on the CRO screen. Let's come to the second part, in which we talk about Y gain setting. Y gain setting, like time-based setting, has a certain options to choose from, and this usually ranges between 5 millivolt per centimeter to 25 millivolt per centimeter. Like time-based setting has usually the options of 5 millisecond to 25 millisecond per centimeter. This is 5 millivolt per centimeter to 25 millivolt per centimeter. This range signifies what will be the height of this trace when a certain voltage signal is connected to it. Clearly, this height is expressed in terms of voltages now, and that is why we have millivolt per centimeter. That means the higher the peak of this, the larger the voltage, the larger the strength of that voltage signal associated with that trace. Suppose this is the trace we are studying, and the selected value of the time-based setting is 10 millivolt per centimeter. Suppose this is the selected value of the Y gain setting, might be given in the question. So now I can interpret the peak voltage. I can inform what is the peak voltage of this signal. One box has 10 millivolt, because 10 millivolt is per centimeter. So one box is 10, another box is 10. That means this is 20 millivolt, the peak value. From 0 to one side it is 20, or to this side. So peak voltage voltage. This is what we calculate using the Y gain setting and the number of boxes now along the Y direction. So there are two values of two boxes. If this is 1 centimeter, that means 2 centimeters are involved here. So 2 multiplied by the same number, 10 millivolt. Because this is 2 centimeter, that centimeter minus 1 will be cancelled with this. So the product will be 20 millivolt. So often in the questions that you usually find in the multiple choice questions, in which there are so many questions related to it, and they often give you a value of the Y gain setting, a value of the time base setting, and then you are asked to identify the time period or frequency and the peak voltage associated with this signal. So this is how we interpret the trace. But what happens to the height of this signal when we change this time base setting? Suppose we choose a smaller value. Let's say this is 5 millivolt per centimeter. 20 millivolt is already known to be the peak value of this signal, and that is not going to change like the time period and frequency. Instead, the number of boxes in which the trace should fit along this direction now will change. And that means, again, peak value will now be, although this is 20 millivolt already calculated,